Let's have a look at how we do calculations involving equilibrium systems. The first thing you should know about equilibrium is the fact that you're going to have both reactants and products in your system at the one time. Not all the reactants are going to turn into products, so therefore you're going to have a mixture of both of these two things. How do we actually have an understanding of how many products and reactants we have? Well, we calculate the thing called the reaction quotient. That's given the term Q. The Q value, reaction quotient, is an indication of how many products versus reactants there are in a system. If you have a very large Q value, it means you have a lot more products than reactants. However, if you have a very low Q value, it means you have more reactants than products. Why is this the case? Well, we need to have an understanding of what the Q value actually is, and this is how you calculate Q. This is a generalized equation for the reaction above, where I've got A plus B forming C plus D. What I do is I take my products and get their concentrations and put them on the top of my equation here. I raise them to the power of the coefficient. I can see here I've got concentration of C to the power of C because my product is C and the coefficient is C. That's times by the concentration of D, which is my other product, and then on the bottom of my reaction, I've got my reactants, which is the concentration of A to the power of A, concentration of B to the power of B. What this is in effect is pretty much the concentration of the products divided by the concentration of reactants. And that is why if you have a large Q value, you have a large number of products because you get a large number on top. If you've got a small Q value, it means you don't have many products because the smaller number is at the top and a larger number down the bottom there. So Q gives you an indication of how many products versus reactants there are in a system. Let's look at how Q changes as the reaction proceeds to equilibrium. At the start of a reaction, I have a large number of reactants and no products, which means our Q value will be close to 0. As my reaction progresses, my products start to increase. So my top number here starts to increase, my reactants start to decrease, so Q will start to increase. It will start to increase until I reach equilibrium, where the amount of products is consistent and the amount of reactants is consistent. So what's going to happen is as my reaction progresses up to here, I increase K because my products are increasing, and then it remains consistent and stable. What this is called is the equilibrium constant, which is my reaction quotient at equilibrium. So this is how you know if a system is at equilibrium. If a system is at equilibrium, Q is constant, and we call that the value K. So if Q equals K, you're at equilibrium. If Q is greater than K, you've got too many products. If Q is less than K, you don't have enough products. What this means is by looking at Q and then comparing it to K, you can find out whether the forwards or backwards reaction will be favored to reach equilibrium. As it says up here, if you have a Q that is equal to K, you are at equilibrium, so life is already good. However, if you have a Q that is greater than K, you have more products than you would at equilibrium, so therefore the reaction will move in the backwards direction to reach equilibrium, because it will want to try and use up those products to come down to the K value, which is the equilibrium constant. If Q is less than K, it means you have fewer products than you should at equilibrium. So the reaction will move forwards to re-establish the K value. This also helps understand Le Chatelier's principle. Because as you can imagine, if we have an equilibrium system that is at equilibrium, we have Q equal to K. If I add in reactants, what that does is it increases the number at the bottom of my equation here. Therefore, it reduces my Q value from the K that we had beforehand. So therefore, the reaction will move forwards to oppose that addition of reactants and re-establish equilibrium. So you can see that the Q value and the K value help in understanding Le Chatelier's principle as well. So this is the introduction to looking at calculations to do with equilibrium, and I'll make a few videos on actual answering questions. So therefore you get to see calculating the equilibrium constant, calculating the K value from a practical point of view as well.